doing revision of geometry. Firstly, we start with adjacent supplementary angles. From the diagram given to us, we're supposed to identify D, and in order for us to do that, we have to remember that that whole angle is 180 degrees. Angles on a straight line are supplementary. So therefore D and the 90-degree angle and 40 degrees are equal to 180 degrees. Therefore D is equal to 50 degrees. The second property that we have to recall is that vertically opposite angles are equal. So for this diagram, we've been given two intersecting lines, and we're asked to find the values for A, B, and C, and we're only given 70 degrees. So the first thing that we need to remember is that A and 70 degrees are vertically opposite angles. Therefore, A is equal to 70 degrees as well. And then we use the angles on a straight line that are supplementary, recalling that 70 and B are on a straight line. A and B are also on a straight line. C and A are also in a straight line. So we can choose any. So in order for us to get B, I use the original angle 70 degrees to get its value. Therefore, 70 plus B is equal to 180 degrees. So therefore, B becomes 110 degrees. And then noting that B and C are vertically opposite angles, therefore B is equal to C. Or I could have just used angles on a straight line, noting that C and 70 degrees are on a straight line. So either way, I would get C to be equal to 110 degrees. Now angles around a point are equal to 360 degrees revolution. Okay, so it means in order for us to get the value for A, then it means we need to just add all those angles and equate them to 360 degrees, and then get the value to be 70 degrees for A. We get two parallel lines. As part of our revision, we have to remember that in order for us to get the parallel lines correct, we need to know its properties and what it means for the angles that are involved. If we have those two lines parallel, then that means we have F, and those two angles are called corresponding angles. And according to the properties of parallel lines, the corresponding angles are equal. And then again, for the second property, if those two lines are parallel, then it means those two angles are called co-interior angles, and the property for parallel lines say that co-interior angles are supplementary. Then lastly, if those two lines are parallel, please recall that parallel lines never intersect, and you have a diagonal passing through both those two lines, then it means that you have N or Z, depending on which way you look at it, and those angles are called alternate angles and they are equal. So co-interior angles are supplementary, corresponding angles are equal, alternate angles are also equal. Let's remember these. I call it fun. All right. Let's do some examples. In the diagram given, we're asked to find the values for the unknowns. Firstly, A and angle C are co-interior angles. Therefore, A plus 80 is equal to 180 degrees because we've been given that AB and CD are parallel. Therefore, A is 100 degrees. Moving on, now we can use angles around a point, meaning A plus 120 plus B equal to 360 degrees. Therefore, you will have 2B equal to 140 degrees, and therefore B equal to 70 degrees. Please remember to always write out the reasons for whatever conclusion that you come up with. Let's go to the next example. B. In that diagram, also we're asked to find the unknowns, G and H. Note that we've been given two parallel lines there. Therefore, 65 and G are equal. They are corresponding angles. And also 42 and H are equal. They are alternate angles. C. Do the same. We're solving for the unknowns. Could start with A. A and 130 are on the straight line PQ. So therefore, they are supplementary. A plus 130 equal to 180, and therefore A is equal to 50 degrees, which makes it so easy then to find B because they are vertically opposite angles and vertically opposite angles are equal. And then again we use vertically opposite angles, or we could use angles on a straight line, noting that if we use RS as the straight line, then it would mean A plus 2x are equal to 180 degrees, and we had said A is 50, so we will have 50 plus 2x equal to 180, so that means 2x will be equal to 130 degrees, and therefore x equal to 65. But for our solution here, we chose to use vertically opposite angles, which gave us this exactly the same answer. 130 equal to 2x, therefore x is equal to 65 degrees. D. We've got three parallel lines here. We can start with A. A is equal to 110, corresponding angles. Please note, now we've got more than two lines parallel, so specify which lines are you talking about. Hence, I said here, A is equal to 110 because ST is parallel to RU. And then we go to B. In order for us to get B, then we have to acknowledge that PQ and ST are parallel. So therefore, we have alternate angles. Again, note that I've specified it in my statement there that ST is parallel to PQ. So B is 30 degrees. From there, we can get to C. I've used RU as the straight line. So it means that in order for me to get C, I have to acknowledge that RU is a straight line. So therefore, angles on a straight line are supplementary, meaning therefore C plus 110 degrees equal to 180. Therefore, C is equal to, I believe C is equal to 70 degrees. And then we go to D. D, in order for me to get D, I could just simply use vertically opposite angles. A equal to B plus D. And I already calculated the value for B to be 30. And I know the value of A to be 110. Therefore, it makes life easy for me to be able to get D. D will be equal to 110 minus B, and our B was 30. Now, number 2. For number 2, we are supposed to prove that the given lines are parallel. We are asked to prove. So we have to remember fun in order for us to do this. It's either you have corresponding angles equal, or alternate angles equal, or cointerior angles supplementary. In order for you to prove any of those is sufficient to prove that the two given lines are parallel. Okay, so we're given 150 degrees and we're given 30 degrees. So CDE is 150 degrees, DFB is 30 degrees. So all I need to do is to find angle CDF. Angle CDF will be equal to 180 degrees minus 150 angles on a straight line. So therefore, I got angle CDF to be equal to 30 degrees, and angle CDF is equal to angle DFB. Therefore, I can simply say those two lines are parallel, stating that we have just discovered alternate angles. We go to B. Again, we're proving AC to be parallel to BD. Note that we cannot assume they are parallel until we have proven alternate angles, corresponding angles, or cointerior angles. In this one, that's the easiest one that we have so far. We have angle A equal to angle B given. Therefore, we have alternate angles. So as our reason here, it's given. Therefore, AC is parallel to BD, alternate angles. You have alternate angles here. Okay, in this example, we asked to prove that AC is parallel to CD, and UV is parallel to WX. In my solution, I chose to start with UV parallel to WX. So all I need are those angles to be corresponding angles, and that's all basically I need. So therefore, in order for me to get angle VPB, then I just have to remember that it's equal to 140 degrees because it's equal to angle APU, and they are vertically opposite angles. And therefore, that angle VPB and angle XQB are corresponding angles. With, therefore, we can simply say UV is parallel to WX. Now, changing directions, trying to prove that AB is parallel to CD. Now, in my proof here, I chose CRU. I'm trying to figure out what that angle is. CRU. I use angles on a straight line. That means I'll get 140 degrees. And therefore, CRU and APU are corresponding angles. So it means that, therefore, CD and AB are parallel. Moving on, we're going to angles of a triangle. Angles of a triangle are supplementary. An exterior angle of a triangle is equal to the sum of the interior opposite angles. If two adjacent sides of a triangle are equal, then the base angles are equal. And then that triangle is called an isosceles triangle. If all three sides of a triangle are equal, then we have what we call an equilateral triangle. Here are some examples. We're supposed to calculate the angles that are unmarked. So that means that's the angle that we're supposed to calculate. So all we know is that angles of a triangle are supplementary. So that means in order for us to get the unmarked triangle, we subtracted the given angles from 180 degrees, and that gives us 50 degrees. And your reason being angles of a triangle are supplementary. We have here two unmarked angles. For the interior angle of that triangle, you can start by marking your vertices. Got A, and then B, and then C, and then D. And then we'll be able to get ACB will be equal to 180 minus 32 minus 56, and we're getting 92 degrees. And in order for us to get ACD, we can use angles on a straight line that are supplementary, and we subtract that from 180 degrees, we'll get 88. Or we can use the fact that an exterior angle of a triangle That is, angle ACD is equal to the sum of the two interior opposite angles. So it's just the sum of 56 degrees and 32 degrees. So angle ACD is equal to angle A plus angle B, and you will still get 88 degrees. So either way, either you use the exterior angle of a triangle equal to the sum of the two interior opposite angles, or we use the angles on a straight line to get the value for ACD. C, we've got two angles that we're supposed to calculate. Let me simply say this one is X and this one is Y. In order for us to calculate X, we need that angle. Or we may not even need that. All we know is that 108 is the exterior angle. It is equal to the sum of the two interior opposite angles. So X is 108 minus 60 degrees. Why are we doing that? All we know is that X plus 60 is equal to 108, and our reason is exterior angle of a triangle is equal to the sum of the two interior opposite angles. So that means we're getting here X is equal to 48 degrees. And then we can use the angles on a straight line. That means we'll have 180 minus 48, giving us 132 degrees. So Y is 132, X is 48 degrees. Or, as I indicated here, we could get that angle, which I'll call Z. We could start by calculating Z, angles on a straight line, because you'll have 180 minus 108, giving us 72. So Z is 72. 72 plus 60, that gives us 132. So Y will still be getting 132 degrees even if we go that route. So we start by calculating X for this problem, because we're supposed to calculate X, Y, and K. X, Y, and K. The first thing that we note is that 2x, that whole angle, is vertically opposite 120 degrees. So therefore, x is equal to 60. So I've got 60 there and 60 also here. The next thing, those two lines are parallel. So we have co-interior angles here. 2x plus 2y must be equal to 180 degrees. So that means 180 minus 120 gives us 60. So that means 2x is 120 and 2y is 60 degrees. So that means y is 30. So we've got 30 here and we've got 60 there. Then we use the angles of a triangle in order for us to get k. So that means 30 plus 60 gives us 90. And therefore, in order for us to get k, we'll have x plus y plus k equal to 180 degrees. Angles of a triangle are supplementary, and therefore we get k to be equal to 90 degrees. Congruency. If we've got three sides of a triangle equal to three sides of another triangle, and your reason is given as side, 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 or you have side angle side, that means two sides and an included angle of one triangle equal to two sides and an included angle of another triangle, or the third reason, angle, angle, side, that means two angles and a side of one triangle equal to two angles and the side of another triangle, or you have right angle, hypotenuse, and a side. That means you've got two right angled triangles. The side and hypotenuse of one triangle equal to the same in another triangle. Then we are able to say the areas of those two triangles are equal. Let's do some examples so that we get to use these properties. And we say those two the areas of those triangles are equal. That is why we are able to say the two triangles are congruent. Number one, we are told that AB is parallel to D, and also AB is equal to D. We're asked to use congruency to prove that AC is equal to EC. That's AC is equal to EC, and BC equal to DC. BC equal to DC. Now, let's write out our proof. First thing, we start with what we're given. AB is equal to ED or DE. AB equal to ED, given. Then we have alternate angles. Angle A and angle E are equal because they are alternate angles. And then we have vertically opposite angles. Then we have the reason angle, angle, side. Or we could have simply chosen to use angle B and angle D. So that would have angle, angle, side. It's up to us. Whatever side you choose to use, whatever reason you choose to use, it's still correct as long as you're going to prove congruency. Because we already have two angles on the side, then these two triangles are congruent. And if they are congruent, that means their areas are equal, and therefore even the sides are equal. For this problem, we asked again to use congruency to prove that Vy is equal to xz. Vy is that side and xz is that side. So let's check what we have. We have Wx equal to Vx. Now, also given is Vy parallel to xz and xy parallel to wz. Now, what I can pick up from here are parallel line. From the parallel lines are alternate angles. The first one is this one, angle y and angle yxz, because of Vy parallel to xz. I get Vy x equal to yx z. And then we go to the other side using the other two parallel lines, looking at xy and wz. I also get parallel. Their parallel lines I also get alternate angles. So I believe that angle WZX is equal to that angle again, angle ZXY. Alternate angles because WZ is parallel to XY. So that means both these angles, angle Y is equal to angle YXZ, and angle Z is also equal to angle ZXY. So these two angles, angle Y and angle Z, are equal. So I have an angle and a given side. Now what I leave to you, for you to do, is to find another angle or another side, so that either you use angle, angle, side, or you use side, angle, side to prove the congruency of those two triangles. And then thereafter, you'll be able to conclude that Vy is equal to Vz. As we move on, we are asked to prove for this problem that xw is equal to wv. Let's check what we have been given. We have yw is equal to zw. Also, we've got parallel lines, yx and vz. From the parallel lines, I have alternate angles. That's the first set of alternate angles. The next one, I hope you do agree with me. Note that we are asked to prove that xw is equal to wv. So it means we're looking at that triangle and that triangle. So we've already have two sets of angles equal and a side has been given. So we have angle, angle, side. So these two triangles are congruent. And then thereafter, we can be able to conclude that the longer side of triangle XYW, which is XW, is equal to the longer side of triangle VWZ, which is just VW. And it goes without saying that even YX will be equal to VZ.